everybody. I just had a few little comments and stuff that I was thinking about that I figured I'd share with you guys. And I want to start out by talking about belts. You know, that back when we had the old V-belts, it was sometimes you'd have issues with these pulleys getting out of line and stuff like that. That's not quite as big of a deal on the old V-belts as it is on the serpentine belts. And V-belts are more likely to actually fail suddenly and just leave than V-belts are. When V-belts do it, it's not because of the belt, it's because of the pulleys. And of course, pulleys or belts can cause it to happen with V-belts. But typically, if you'd have several V-belts, you know, pulling various different things, alternator, power steering, and all that, air conditioning, and one belt could break and get involved with all the other belts. And you hear stories about people that were out there without any kind of a spare belt, and they would use pantyhose to make a belt out of it and stuff like that. I mean, I guess whatever you have to do, you know. I never have used pantyhose to make a belt. I typically, when I was driving cars with V-belts, would carry a spare set of belts with me in the vehicle and the tools to change the belt, because you don't ever know what's going to happen, or you're never going to have all the tools you need for every little thing that may go wrong. But these Power Stroke diesels, see this big old wide pulleys down here and all that, that's basically the, you know, you have various different widths of serpentine belts and everything, and I've showed you those shiny ones that used to be made by Dayco, but they hadn't made them anymore. They used to make they were fluted looking belts that had made a whirring sound and all that. But I mean, I hadn't seen any of those belts in a long time, and I think they quit making them. But when belts are seating like what they're supposed to, and I got this from Gates, they basically are going to have traction right here. There'll be good traction right here, and this is where they evacuate water. Basically, that little place down there in the bottom is where water can get out of there, and it's kind of like the tread on a tire, but the pulley is specifically made to run with the belt so that it has good traction and water can get out of there. It's designed that way. We don't often think about that, but it is. But once you get to the point to where the belt is worn out, to where this is thinner, and you wind up with this rib digging into that, and if you look at a belt down in these grooves, you see how shiny it is down in that groove right there? You might recognize that. That typically means that that pulley is digging into that and it doesn't have the traction it used to have. Now those belts will still work like that for a while, but even a belt that's not showing any cracks across its ribs can be a belt that needs to be replaced. And there's the tensioners, and I've talked about those tensioners till I was blue in the face. This was one of those tensioners that we had put on, and we found out later that it was running out of line. See how this thing's so out of line with everything else? I mean, that belt ought to be perfectly in line like that. But those tensioners, and Dayco was terrible to make tensioners that would get out of line too. I got to the point to where I didn't want to use any Dayco tensioners because the Gates tensioners were a lot better, or the OEM tensioner. And the Gates tensioner looks just like an OEM tensioner to me, but the Gates has got its own little design. But I'm not just hating on Dayco because I don't like Dayco, because I've used Dayco belts and stuff and all that. But their tensioners I don't care for. Now, these Power Strokes, and this is a picture of a Power Stroke diesel down here. You might notice, if you've ever looked under the hood of one of these diesels, when you shut it off, it's got so much compression that when it stops very suddenly. And it can bounce the tensioner. In the early days, it would bounce the tensioner and the belt would jump off. You know, you switch off the vehicle without warning, suddenly you wouldn't have the belt, and then you start it up and, you know, you'd have alternator light on and all this kind of stuff. Well, you know what, this was happening early on some of the Power Strokes, 7.3s. Ford came out with a fix for this, which I thought was very interesting. What they did was, the original pulley was flat. Let me get rid of that stupid red stuff there. The original pulley was flat on the bottom and the top like this. And the pulley they sent to and this is just the idler pulley now, is what it is. And I think there was one on the tensioner or one on the idler or both, whatever. Anyway, it would be have a curve like that. So what that would do is it would stretch the belt in the center and make it so that it didn't want to jump off because it was tighter on the edges than it was in the middle. Now, interestingly enough, if you look at some of your vacuum cleaners, like for example, Rainbow vacuum cleaners, the little rubber belt that drives the beater bar on that the pulley is designed the same way. It's just a flat belt, and it's a little rubbery flat belt. But they made that flat belt so that, and this pulley rides on the back of the belt too, by the way. When they put that slightly convex pulley on there and replaced the original flat pulley with a convex one, those belt problems went completely away. And that was a very simple fix for something. And, you know, those engineers have to come up with stuff like that. But I thought that was a very interesting thing, especially when I started noticing that the pulleys were made that way on these Rainbow vacuum cleaners and had been for years and years and years. So somebody was aware of that. They probably learned it in engineering school. My VW diesel air conditioner, you know, I don't know, back in the day, those VW diesels were basically a higher RPM diesel. They turned 5,000 RPM, you know, which is unusual for a diesel, but they didn't have a whole lot of power. And the problem with them not having a whole lot of power was when you went to accelerate into traffic, even if you were really getting on it, they just wouldn't do that well. And so, you know, there were some tricks that I learned at Volkswagen school where you could help a little bit with that. And like, for example, he said set all the intake valves as tight as you can within specs and all the exhaust valves as loose as you can within specs, and then make a little adjustment. He showed us how to make a little adjustment on the injector pump fuel delivery so that it would give you more power. And I did that, and it made a difference on the way the thing ran. But I still wasn't satisfied with the power that my 83 diesel Rabbit was doing. And of course, it had several 100,000 miles on it by the time it was retired. It was a car, when my son was 18, I gave it to him, and he loved that car because 55 miles to the gallon's hard to beat. Anyway, I added a relay. I talked about this one time before, I think. And I used, so they had an upshift control unit, which basically would turn on a light on the dash when it was time for you to shift to the next gear, and it would maximize your fuel economy. That was something that Volkswagen did. And they had an idle switch and a 70% throttle switch. And so I fixed it so that the relay coil was being grounded when you went to wide open throttle, and I had the normally closed terminals on the relay driving the AC. When the relay was energized, this would snap over and you would drop your AC clutch, and that would give you some extra acceleration, which was considerable when you were using the AC. You know, the AC pulls quite a bit of a load on that thing. Anyway, that was a little thing that I came up with that really helped me out whenever I was trying to accelerate and getting into traffic while I was using the AC. This is scoping a misfire. You know, we've talked a little bit before about the ignition systems, and whenever you're scoping the ignition system, this is basically, for the most part, what you want to see. This area on this side is going to look a little different from vehicle to vehicle and from system to system. But basically, when the spark plug fires, this is when it first jumps, and this is while the spark is burning. And as the fuel is used up, you get this upkick, and then you get some leftover energy here that goes out like that. Well, we had one that was misfiring, and it was on Nissan or something. I can't remember what it was on. But we scoped it with the Pico scope, and we got this really nasty, ugly looking, you know, it was supposed to look more like what you see up here. You know, and basically what it looked like was something terrible, like you see right here. And when we pulled the spark plug out, you see that flash over that was running down the side of that plug? Once again, when you see that, that's when you need to replace either the boot or the plug wire or whatever that you need to do. You don't need to put the same boot back on here, or you're going to have another flash over even if you put a new plug in it. But that scope pattern, you know, we also had a cylinder number 2 misfire and a cylinder number 3, but this one right here was one of those, and it was the worst one. So I just wanted to share that with you a little bit. But there's all kinds of articles online where you can read about this. But I learned about these scope patterns in 1983 working at the Volkswagen place, which was the first time I ever really used an ignition scope. There was a scope that was on a track that you can move around from service bay to service bay. It was really cool. And it was a sun scope. And one day I got one that was sputtering and cutting out, and I put the scope on it, and whenever I would rev it up and it would sputter and cut out, this right here would be really loud. I mean, just really, really busy and loud. It wasn't like that unless I was really getting on it. And it turned out that one was not an ignition problem. It had a clogged up fuel filter. It was really bad clogged up. And so whenever I replaced the fuel filter, that went away. But I could see it happening on a scope, a lot of turbulence during this burn time is what that was, because it was not getting enough fuel, and it had a lot of resistance in there, because the fuel actually helps conduct the spark until it goes away. As you know that because you got this, as the fuel molecules are used up, it kicks up right at the end. So that's what the deal is on that. Now these charging system battery testers, I got a BT608 Autel, and it's fairly pricey, but it's not as expensive as this Medtronic deal over here. I used this one at the college, and it cost like $1,700 when I bought it. I don't even know that they still make this one because I couldn't find one online. But when I bought this one over here, it cost $1,700, and it takes you through a test where it tests the battery, and then it for cold cranking amps, and you got to put in how many cold cranking amps it's got, and then it has you turn on the lights, turn off the lights, start it up, start it up, it tells you how to do all kinds of stuff, and the whole time it's checking things so that it can basically do a comprehensive evaluation of the charging system. Now this one right here was on a 2019 F-150 that kept killing the battery. In the end, it turned out that he had wired up his trailer tow box wrong, and that's what was killing that. But whenever the battery was weak, I mean, he had it in there, and I hooked this tester right here up to it, this BT608, and I ran through the test on it, and it said to replace the battery. A state of health, SOH was bad. There was said to do that, and this thing's even got a camera on it where you can take a picture of what the battery looks like, and include it with your report. But you see this little the millivolts. You can look at the pattern, and you can also look at how many millivolts. Now this pattern looks really good on this stator, but the millivolts was too high according to the tester and all that. So that was a pretty interesting little thing too. The ripple is a really important part of that. You notice this one up here was also looking at the ripple. See the ripple on that one? And it basically looked at, see if you had a diode problem, that. But see, this tester and this tester are very similar. Where the difference is, this tester here also has a built-in scan tool. It also has some little adapters. You notice you also plug this one into the OBD port even while you're doing your charging system test, and it uses all the information it gets from there. And it also will do a scope trace sort of with a voltmeter, volts, amps, whatever. You can set it up. It's got it'll draw you a little scope screen. I mean, this one right here has got a tremendous amount of ability. BT608 Autel, that's what that is. So just keep that in mind. I've got one of these that belongs to me. I would not buy one of these because it won't do what this one will do. This one will do everything that will do. Furthermore, if you want a printout like this printout right here, you can basically get it from right here. This has got a built-in printer, and if you tell it to print, it'll kick you out a printout just like that with your shop name and the serial number of the vehicle and everything on it. And it gets the serial number from the OBD. Alright, now when you're repairing brake lines, you don't ever use copper tubing unions. Now you might notice that one side of this brake line is rusty and the other one's not. But this right here, you need to have a double flaring tool, which doesn't cost that much. It takes a little practice to use it. But if you've got a double flare union, and you've actually repaired, if you got a brake line that's leaking or something like that, and it's not so rusty that it's thin all the way through its whole length, or it's like I say, if something's happened to it, you can basically cut out the part that has been damaged and is leaking, and you can double flare it and use this kind of union here is what you're supposed to use on brake lines, because they hold about 2,000 pounds of pressure. A copper tubing union is totally unsafe for fixing brake lines. You can do a lot of other stuff with copper tubing unions, fuel lines, lower pressure stuff, transmission cooler lines, that kind of thing, because they don't have about 35, 40 pounds of pressure on them. But just make sure that when you do a brake line repair, you do it right. Pay close attention to how rusty the brake lines are too, because you may need to replace the entire brake line, and if it's a long one, it may be a little aggravating to do that, but you don't want your brakes going away. I've actually had brake lines bust while I was driving a vehicle and start squirting fluid out, and the pedal goes to the floor, and suddenly it's like stepping on a plum and you can't stop. Now, this was a customer working in the dark just by feel, which I thought was kind of interesting. He says, hey, my radiator, my hose is still leaking, even though I changed it last night, laid it in the grass. He didn't have a light or anything. He was just trying to feel of it under there. And when he tightened up the clamp, he tightened it up on the neck instead of on the hose. And sometimes that happens. You can't really, any of us could make that mistake working in the dark, when we're in a hurry, when we're frustrated. And so we went ahead and just moved that clamp. See, it's a brand new hose. You notice it's never had a clamp on it. This student, he told me he was all done putting this water pump on, and I said, wow, you did that quick. So but he said, I hadn't put any coolant in it yet. Well, he came in late the next morning, but we had already tried to put coolant in, and it just was pouring out everywhere. And when I got an angle on it with my camera where I could take a picture, he hadn't even tightened that bottom bolt. The gasket was all loose and everything, and coolant was running out. And I was thinking, boy, he sure got through with that quick. But it was a sloppy job. It was like not doing anything at all. And so, he didn't really have anything to say for himself. But this is you make the wrong kind of mistake, you could cause some serious damage, if you're not paying attention to what's going on. Of course, this was hard to miss. You pour the coolant in and it starts running out around the water pump. Now, this was replacing a seized ignition lock cylinder on a Ford Focus. Those were problematic when they first came out, and there was a lot of them that had to be replaced. And basically what you had to do was make marks like that with a pencil, like that right there, and then drill right in the middle. And then you could take after you drilled it, you'd have to work it out of there, using a screwdriver. Once you drill out all the little tumbler thing, you usually turn it with a screwdriver and get it out of there, because it's got to be turned to the own position to pull it out. And I have seen Chevy vehicles do that. I've seen Fords do it. I've seen Saturns do it. The suddenly locked up ignition lock tumbler on one that has a key. Most of them are push button nowadays. But if you've got a locked up ignition lock tumbler, that can happen to any ignition lock. I don't care who made it. And what I always had to do the first time I ever ran into it was in a Thunderbird, and I had to drill the thing out. And they have on that Thunderbird, they had some little really hard pieces of metal on either side of that key slot, so it was difficult to drill out. And so I had to work down past those and then get them out of there, and then drill on down in there. And then I would drive a big screwdriver down in there and turn it to the own position so I could get the lock cylinder out, because you got to turn it to the own position, you got to know where the release is, hit the release, get it out, put another one back in there, and so on and so forth. But this lock cylinder here, lock cylinders are something that we used to have to do at the dealership all the time. Now, the plugs fired by the same coil, and this is coil pack. Now, this is where you got the same, like if you have a 6-cylinder, you'll have 3 coils, and each coil fires 2 plugs. And I talked about this a little bit before, but I noticed on the Crown Victorias, the plugs on each bank had exactly the same wear pattern, but one of them would look like this, and the other one would look like that. On the same car, the plugs had been in there the same amount of time, because on one side, the spark pops out, and on the other side, it pops in. You got more wear on the ground electrode here than you do on the center electrode, but you got more wear on the center electrode than the ground electrode here. So you're going to see that because the spark is always traveling in the same direction. It makes a loop. It's what it does, through the block and then the coil and all that kind of thing. And that's how that works. I told my shop foreman, I says, I've noticed all the passenger side plugs and all the driver side plugs all have the same wear pattern, but they're different from bank to bank because of the way that they structured these coils. They just didn't do this randomly. They basically set it up that way, and that took some doing to figure that out. This was from a happy customer. I always like getting these kind of messages. She sent me a text message, and she was an instructor at the college, and for years and years when I was over there, we worked on her Honda every time it needed an oil change or anything done. And when it hit 300,000, she took a picture of it and sent me this text. The Honda, and I made it thanks to you. Hondas usually do pretty good anyway. And it was kind of funny. This one student of mine drove a Honda Passport he had bought from his grandfather. And he told me his grandfather told him that nobody should ever own any car except for a Honda, because that was the only real car out there and all the rest of them were junk. And so I thought that was a silly bunch of nonsense. So I says, come in there, let me show you something. He had been very impressionable. I said, with all due respect to your grandfather, I just went on a random search, had never done this before, and I typed in problems with Hondas or something like that. And I came up with a website, and I don't even know if it's still up. And the website was hondasucks.com. And there was page after page after page after page of people talking about the problems they'd had with their Hondas, and they'd never own another one. I'm not hating on Hondas, you know, a lot of people like Hondas, and Hondas are okay. I kind of like the way Honda does their gasoline direct injection, because they make it just as simple as they possibly can, instead of having all of these fancy low side fuel pump, you know, modules and all that kind of stuff. They just put a regular fuel pump in the tank that regulates fuel pressure to the system up there, and then all of the decisions about high pressure is made up front. I mean, if you compare a lot of these GDI systems, that Honda one's probably the simplest one out there. This is the resolver from a hybrid electric drive motor. You probably won't ever see this again, but that resolver basically sends input back to the controller while it's driving the motor, so it can get maximum efficiency. It's just an interesting little piece of hardware. I took this picture when I went to a hybrid school back in 2010 up in Rhode Island. Actually, I was in Massachusetts. This is extreme carburetor basics. You know, anybody still interested in carburetors, you might notice that you got this jet, and whenever the pressure comes in through this venturi, it causes low pressure that draws fuel up out of here, and it mists it in there. Now, whenever the throttle plate is closed, this idle mixture screw, which is not, you know, it's basically a little pointy screw right here, and it controls how much fuel is coming, is going in when it's idle. So it's running, the fuel it's running off of when it's idle is going past that little that little pointy end of that idle mixture screw. That's why when you turn the idle mixture screw, you know, that pointy thing, you're, you know, stopping up a hole, all that. But this right here, and here's your little power valve on the car. Not every carburetor has a power valve, but if you've got a power valve on there, you know, you might notice that whenever there's plenty of vacuum, well, like with a low load, it closes that. But whenever there is a reduction of vacuum due to load, this spring pushes that diaphragm up because the vacuum can't hold it down anymore, and additional fuel goes in. So that's called a power valve. You know, some carburetors had two-stage power valves and that kind of thing. But the president of the college, what he did with his Cadillac, 71 Cadillac, he took and he had another carburetor over here that he had plugged the vacuum into, and he would watch that power valve, and he wanted it to float when it was idling instead of being one way or another, some kind of way. And he kept altering the little spring under there until he got that thing doing just like he wanted to. And he increased the fuel economy on that Cadillac by playing with that power valve from, I think it was getting 10 miles to the gallon. He got it up to 13 fooling with that, which is a victory when you're talking about a 500 cubic inch 71 Cadillac Eldorado. Now, this vehicle, and it was a GM vehicle of some kind, they were claiming in the shop manual there were supposed to be holes somewhere here on this panel so you could reach in there and release the airbag, as I remember. I don't remember the exact model of car, but I remember taking this picture because it was irritating. You look at the shop manual, you want to go look at the, the graphic of where this hole was supposed to be, the line art, and you go look here and there's no hole. I say, well, I don't want to drill a hole. I mean, what are you supposed to do to get the airbag off, That's ridiculous. I don't even remember how we got the airbag off, or we may have decided, I can't remember, but in one way or another it's annoying. There was another GM car where the book very plainly said there were bleeders for the cooling system, and when it showed you with a little arrow and some line art where the bleeders were, when we went there, they weren't there. And so I had to figure out another way to bleed the air out of the cooling system. Now, these GM sending units were really lousy back in the 00s, and they would wear out. You notice how these fingers dragged across here until they wear out and they're only barely touching. Sometimes one of the fingers would come slam off of there, and you could get a brand new sending unit, just the sending unit, from the Chevrolet place, and that was something like $145. You pull a pump out, swap out the sending unit, put it back in, you got a gas gauge that works all of a sudden. But on those mid-2000s Chevys, the needles on the instrument cluster had a tendency to go wacky, and there's all kinds of little kits you can buy that come with all the servo motors for the instrument cluster, and they can send you a soldering iron, some solder, a little needle thing to pop the needle off with. It's really cool. And I rebuilt some of those instrument clusters, and it's a fun little bench job to do that. You don't have to replace the cluster when the needles go crazy. Just put the servos on there. Heck, they sell the kits on Amazon to do that. Now this time we had a really bad injector leak, and it was just flushing fuel into one of the cylinders. And to find out what's wrong with that, is it the injector or what? First I needed to isolate which one it was, because you couldn't tell. This was on a 300 SC Lexus, as I remember. And so we went ahead and I disconnected the fuel filter, and I put this little adapter in it to stop the fuel filter up so it wouldn't leak everywhere. And then I took this cylinder leakage tester, which you can actually regulate the air there, and I connected it to the line that had come to the fuel filter. So I took a hose and put on there and clamped it. And so I went ahead and put 40 psi in that fuel line, and while at the same time I had this other adapter in here with my Mac fuel pressure gauge connected to it, because there was no other fuel pressure connection port anywhere on this darn thing. And that Mac kit had a whole bunch of different adapters. You could do stuff like this with it. You pull that banjo bolt out and put a fitting in there, and then snap your, click your quick connect hose onto it for your gauge. And I put 40 psi of pressure in that system. You could hear it hissing into the intake. And I determined from unplugging injectors that it only did it with the key on. It didn't do it with the key off, so that meant the injector itself wasn't the problem. So I turned the key on, I unplugged it, and found number 3, as I remember, was doing that. And I said, okay, now we're going to disconnect the engine controller and see if it still does it. When we disconnected the engine controller, the hissing went away. That meant the engine controller had a driver that was keeping the injector open all the time. We sent it to A1 Cardone. They rebuilt it for $400, but if you'd have bought one, it would have been $1,700. So anyway, we got that one going again by replacing that engine controller, and it worked really well. Now this is the Toyota versus Ford parts prices in 2010. Toyota parts are really high anyway, but you see this little vapor pressure sensor was so small that you could almost put it in your mouth and close your mouth and nobody would know it was there. That's how little it was. $180. And it's not that it's a whole lot better than anything else, because these things fail, because we had to replace one because of code it was throwing. On this, about the same time, there was a Ford 500 that we replaced the accelerator pedal assembly and the throttle body, and the price for both of those from the dealer was $155. So you got this one little bitty part right here that does very remedial work that you just about run the car without it, to this other one that's really important parts. It takes a lot more technology to build these than it does that. So you got $155 here, $180 there. I don't know what the price on these parts is nowadays, but I wouldn't be surprised if it didn't pretty well stay the same. Now you can mix these up, mix up vegetable oil and the hot chili habanero, the hottest hot sauce you can find, and you can spray it on your wires if you've got issues with critters chewing on your wire harnesses. Just spray it good, just wet it all down with this, the oil and the hot sauce and all that. And as soon as they take a bite of it, they'll decide they don't want to burn their mouth anymore, and they'll go away. Honda makes some tape that's got pepper sauce impregnated in it, so that as soon as a critter starts biting your wires, they'll decide that it's a bad idea and they don't want to do it. Now, whenever you're putting timing belts on like this one here, those timing those camshafts like to turn this way and that because they're squeezing valve springs and all that. So once you get your timing marks lined up, you put these clips on here to keep that timing belt from jumping a tooth or two on you, because if it does that, you got issues. And so this was just one I took a picture of while we were doing that, and that's just a little bit of a pointer. Now the Ford Duraspark wiring works this way. This one's hot in start, the white one is, the red one's hot in run, coil primary is the green one, and these 3 wires go to the distributor. This one here provides a ground from this place right here. In other words, the black one is a ground. See how that is grounded? That provides the ground, and the module uses that ground to fire the coil. You could actually clip this ground wire and the car wouldn't even start, or if you had left that screw out like some people might do because they thought it wasn't important. If there's not a good ground here, it won't start. This part store one time, my 80 model pickup, I talked about this one time before, the module went bad, and I could tell the module was bad because it started sputtering and popping and cutting up. But I could turn it to just slightly to the start position so that I was sending power to the start wire on the module, and it would clean up and run good. And I said, well, I know that's the module because the run part of the module is a separate internal circuit than the start part of the module. And so I said, well, what I'm going to do here is I'm going to take this coil. Well, I got another story to tell you about that. So I went over to the part store, and I said, and the guy at AutoZone brought me this Wells part. You know, it didn't look like this one, but it was supposed to do the same job. And the truck wouldn't even start. It would start and idle with my module, but it wouldn't even start with his module. So I went and got another one. He tested it, and he said, no, it's bad, and I'll give you another one. So he gave me another one, tested it first. I put it on there. It wouldn't start the truck either. So he tried to act like I was trying to troubleshoot with his parts. I said, no, and I told him how it's wired up. I said, those modules you've got in that machine you got are junk. I said, that machine doesn't load the module. All it does is, you know, ohm test it or something, because it won't start my truck. And so he says, well, I don't know what's going on here. So he gave me my money back, and I went down to Advanced Auto Parts and bought one like this one right here, and it started the truck. But anyway, that's a reluctor, and it goes past that pickup coil, and it creates a wave like that, you know. But what the other little thing this guy borrowed, there was one of these that had some broken wires down here in this grommet, and I actually went in there and scraped it off and soldered it together and fixed it so I could use it for a test module. And this knothead at the Ford dealer borrowed that module from me. And he, when he brought the module back, it was one with green paint on it. It wasn't even the same module. He had used my repaired module to fix somebody's car and was trying to give me their bad module. That's always makes you want to be really happy to loan the guy something else, you know. Now, one of the things that I did notice was whenever a shop ran, or somebody out in the real world, not outside of the dealership, ran into a problem where the ignition quit, now they run into this independent shop, they'd always replace the module, and that would take care of it. When the module didn't fix it, they'd bring it to the dealer, and we'd always find the stator would be bad. And so, it's go figure, you know. You'd have to work this, you got to use a couple of brake spoons to ease that reluctor up off there, because it's cast iron, and it's got a little roll pin in there so that it's indexed properly, and that's something you'll see. And then you replace that pickup coil. It's fairly easy to do, put it all back together, and you got to get started. But look at this thing right here, what I did one time. I did an experiment on my 74 F100 where I took a Chrysler module and an electronic ignition distributor from a Ford, and I put that Chrysler module on there and wired it up to this. All I had to do was run this wire out to the coil, this in from the ignition switch, and these two, and I had a harness that would plug into this, and these two come from the pickup coil. And the odd thing about that was on a Chrysler, the reluctor points are really, really sharp. On this one, they're kind of fat. So for some strange reason, this one would only start if I retarded the timing first, and then I could advance it and drive it. But I wasn't going to retard. I'm talking about turn the distributor and retard the time, and it'd fire right up, kind of like a Model T, you know. Turn it back around, it would drive and have good power. But when you switched it off, it wouldn't start again until you turned it around. I mean, that's incompatible. If I'd have sharpened off the reluctor teeth so that they would send a signal kind of like a Chrysler one did, I might have done better. I don't know. But that was just something I was playing around with when I was driving it. That's when I was working in Texas back in the late 70s and early 80s. This was me at the dealership doing some work on the dash I'd pulled off. I basically had to replace all the wire harnesses and stuff on part of the one under the dash on a Thunderbird. The guy had burned up the wires by hooking a trailer tow package up wrong. But anyway, I just wanted to give you that shot right there. Well, until next time, and hey, let's be careful out there. See you guys.